Throughout 2021, we have seen Ethereum mainnet become increasingly congested through the growth of both the DeFi and NFTs. This has given the network an unprecedented demand for its block space. We can't simply change the number of transactions we can fit in a block by changing its gas limit, because it would make nodes harder to operate as the hardware requirements would soar, decreasing decentralization. And if the blocks become too big, it would destabilize consensus, which decreases security. Welcome to Ethereum Audible, Ethereum in Depth. I'm Yoshua Zlatogorsky, and welcome back to another episode. Today we are going to be reading through the ultimate guide to L2s on Ethereum, and this will be, in a way, wrapping up a lot of our discussion that we've been having on different kinds of ways to scale blockchains, leading up to the Ethereum merge that's happening in the next 3 to 6 months. Ethereum 2.0, or however we're calling it these days, because the names are changing once again. But this is really, as its name, the ultimate guide to L2s on Ethereum. This runs through a lot of the different kinds of layer 2s out there, tools you can use, why they're important, the benefits and downsides of each one, and with this put together with all of the different episodes we've done up until now on what a rollup is, how it works, how it speeds and increases the transaction throughput on Ethereum, this will give you a really good idea of what a modular blockchain future looks like. But first, I want to thank the sponsors of the show who made this episode possible. This episode is brought to you by Alpe Audio. Want to learn on the go but need more depth than a podcast? Alpe is the app for you. It's an audio education app that brings great in-depth courses that are as fun as podcasts but as educational as a degree. Each lesson comes with summaries, additional resources, flashcards, and more. You can even find Ethereum Audible on Alpe with all of those additional resources. If you want to check it out, head over to get.alpeaudio.com, and that's A-L-P-E, Alpe, A-L-P-E. Let's go. The Ultimate Guide to L2s on Ethereum by DCBuilder. Who am I? I'm DCBuilder, a blockchain researcher at Moralis, where I write about DeFi, NFTs, DAOs, L2s, MEV, and other various topics pertaining to Web3 and crypto. I've been a front-end developer with an AI and ML background, and I've recently started the transition to full-stack blockchain development through an Ethernaut DAO mentorship with Austin Griffith. I'm a fellow member of Wafis Anonymous, being an anime manga enjoyer, and have a Kaneki profile picture on Twitter. Introduction. In this article, I'll talk about L2s on Ethereum, the state of the current scaling ecosystem, and why I believe running L2s on top of Ethereum is the most economically and technically sustainable solution for scaling long-term. Disclaimer. This article aggregates my thoughts, other people's resources, and miscellaneous technical information. It's not meant to be a concise summary of the ecosystem, but rather a more detailed and verbose overview of the current state and future feasibility of Ethereum L2 scalability. To dive deeper, we need to get a few definitions and concepts out of the way. TLDR. To summarize this massive guide, I will keep a running list of important points about the technology and its future outlooks. 1. Users won't ever interact with Ethereum mainnet, as this will only serve as the data availability layer for L2s. 2. Web3 applications' UX will have all complexities abstracted away. 3. Modular blockchains are the most economically and technically viable long-term scaling design option. 4. Currently, Ethereum is the dominant blockchain in the modular domain, as it has a very strong security which will greatly increase with the switch to proof of stake. 5. Validity proofs are better than fraud proofs long-term. 6. The Volition Layer 2 infrastructure, as in Validium plus ZK rollups, is emerging as the golden standard for ZK virtual machine-based L2s. 7. Ethereum is also scaling as an L1 with data sharding, Verkle trees, statelessness, and other changes. 8. L2s are on pace to build a shared cross L2 communication framework which will enable them to have shared liquidity and smart contract composability. 9. L2s use ETH for gas, but are incentivized to create DAO governance tokens to decentralize operations over time. And 10. The application design space is growing now that builders have more bandwidth and less execution layer hurdles to work with. What is an L2? An L2, or Layer 2, is a type of scaling solution that has a separate execution layer, where code runs, as in the EVM, the Ethereum virtual machine, that inherits the security guarantees and decentralization of the network it's running on top of, as in the Layer 1. Ethereum in our case. This means that if the Layer 2 were to go dark due to a bug, infrastructure exploits, or outage, the funds are safely secured by the L1 within a smart contract bridge. The funds can be retrieved according to the latest state snapshot submitted onto the mainnet. The bridge of a true L2 is fully permissionless and decentralized, so there's always a guarantee the funds are accessible once deposits by users. Several scaling approaches use distinct cryptographic proof mechanisms with different security and scalability trade-offs, which we will discuss further in this article. What are the main types of Layer 2s? There are two parameters that are used to categorize Layer 2 scaling solutions. One is the type of cryptographic proof used, and the other is whether the data availability is off-chain or on-chain. The two main types of proofs are validity proofs, which are mathematical proofs that utilize zero-knowledge cryptography in order to ensure the validity of a transaction, and fraud proofs. These proofs introduce a so-called dispute time delay. Once a proof is submitted in the Layer 2, the validator has time in order to mark the proof as invalid. An invalid proof could have incorrect state transitions, and thus result in penalizing the validators involved. A rollback of the state to the latest valid snapshot will follow. What does it mean to have data on-chain or off-chain? For on-chain, the state data, along with all of the execution call data of all transactions, as in smart contract function calls, native token transfers, and signatures, are put together into the cryptographic proof of a bundle or a rollup of transaction, which make all of the data accessible and verifiable on-chain. When it's off-chain, the execution call data and the state is handled and held off-chain by the Layer 2. This makes it a less secure and decentralized option. However, it is much easier to bundle more transactions into the rollup, thus scaling much faster than on-chain call data proofs. These are the main relevant properties that help distinguish different types of Layer 2s. But why Layer 2s when we can scale Layer 1? Why not use a cheaper chain like Solana, Phantom, Avalanche, or Binance Smart Chain? We'll answer that in the next section. Modular versus monolithic infrastructures. In blockchain, there is a famous trilemma that tries to optimize for three main factors: security, decentralization, and scalability. All three are very hard to achieve within the same system. Often, two of the three are attained with a compromise on the third. In the case of Ethereum, we optimize for security and decentralization first, while working on scalability as a lower priority item. To be clear, scalability is not the main priority of core Ethereum developers. Throughout 2021, we have seen Ethereum mainnet become increasingly congested through the growth of both the DeFi and NFTs. This has given the network an unprecedented demand for its block space. We can't simply change the number of transactions we can fit in a block by changing its gas limit, because it would make nodes harder to operate as the hardware requirements would soar, decreasing decentralization. And if the blocks become too big, it would destabilize consensus, which decreases security. Monolithic blockchains. Other chains have taken a different approach where they prioritize scalability first, security second, and decentralization last. Let's consider the Solana mainnet beta as an example. The network has one main client development team, Solana Labs, about 1,000 validators, and a different consensus mechanism called proof of history. Solana has taken a distinctive path for scaling, which is of a monolithic blockchain. They plan on indefinitely scaling the validating nodes operating the network as increasing computing power becomes available. This approach makes the network less decentralized, as the node validators are forced to keep buying better performing hardware to constantly keep up. There are concerns about the rate of growth of computing power slowing down as we reach the limits we can fit inside a chip due to quantum tunneling. At some point, we'd require a new computing paradigm to come along or a large breakthrough in technology to make this approach sustainable. Thus, my conclusion is there are better long-term alternatives to blockchain scaling. Modular blockchains. The modular approach essentially consists of a primary network that prioritizes security and decentralization so that it can act as a data availability layer for L2s. If the primary network were to go down, all L2s would go down. However, if an L2 were to go down, all of the funds are safe and secured by the L1. This is the approach that Ethereum is taking, as L2s will be the layer that will provide the most scalability. There are also efforts to scale the L1 through data sharding, state expiry, and Verkle trees, along with various other improvements. However, these changes take considerably more time to implement as security and decentralization take precedence. A key aspect of modular blockchains is that they can scale indefinitely without having to upgrade hardware at a fast pace. They can do this because they are technically and economically sustainable, in contrast to monolithic architecture. The more elaborate argumentation for why a modular architecture is much more sustainable than a monolithic one can be found in this article by E. Paulinia. And I will link to that, and it's actually an article that we've already referenced and read a significant section of it. In essence, the sustainability of a blockchain breaks down into two requirements: technical sustainability, which means nodes need to be in sync. There's sync from the genesis of the blockchain in a reasonable amount of time, and you have to avoid state bloat getting out of hand. And economic sustainability. The L1 ideally generates more revenue than the cost of operating the network. Centralized layer 1s do not. And throughput can't be artificially increased because eventually all centralized L1s will have to increase their fees. Rollup and data shards emerge as the only solution meeting these requirements. That's why a modular architecture is the only long-term feasible scaling approach. For a more complete explanation of why rollups and data shards are the only solution for long-term scaling, read E. Paulinia's article, The Current State of L2s and How Users Can Benefit. We are scaling now. Many solutions that were in the works for the past few years are already live, at least in a limited capacity, and many more are releasing improved versions and alpha releases of their L2s on mainnet in the near future. These scaling solutions fall into different categories according to the properties of their scaling approach as described in the Types of Layer 2 section. Here's an incomplete list of Layer 2s. Optimistic rollups. Arbitram. Arbitram is an L2 built by the Off-Chain Labs team. The network itself is called Arbitram 1, and it utilizes optimistic rollups in order to scale Ethereum. Arbitram 1 utilizes fraud proofs and has an on-chain call data availability, meaning that all of the data of each transaction is fully sequenced, bundled, and submitted to mainnet. Since it utilizes fraud proofs, there is a dispute time delay of about 7 days. Once the disputed time delay passes, the state changes on the network can be considered valid, and users can withdraw their available balances through the native bridge. There are other centralized bridges that we'll discuss later that allow you to bypass this fraud-proof period by having cross L2 liquidity pools. Arbitram 1 is currently the L2 network that has the highest total value locked. A great website that allows us to inspect these metrics is L2Beat. There are many protocols and applications that already support Arbitram, including supporting infrastructure that makes the switch to using the Arbitram Layer 2 almost seamless. The only current issue with using L2s is that it needs to accrue more liquidity and innovative solutions, like cross-L2 AMM structures like DAMM. And liquidity protocols like Connext and Hop need to get enough liquidity and become trustless enough to the point that all of these scaling solutions can share the same infrastructure, so as to not cause ecosystem fragmentation. For an overview of the Arbitram ecosystem of applications, go to the Arbitram portal page. Key tools. For the Block Explorer, you've got Arbiscan. The bridge is the native Arbitram bridge, and the network RPC configure is Chainlist. You can find all of these in the original post. Arbitram Nitro. Arbitram Nitro is an upgrade to the Arbitram 1 L2, which replaces the custom-designed Arbitram virtual machine with a WebAssembly virtual machine, target that will take care of fraud proofs. This will also make the entire system more compatible with the EVM. Another change is that EVM emulator is being replaced by Geth, which is the most run Ethereum client today. The ArbOS component is also modified to provide cross-chain communication, and a new and improved batching and compression system to minimize L1 costs. This upgrade will be rolled out seamlessly, so users won't have to do anything. The upgrade is estimated to increase execution speeds by 20 to 50 times and considerably reduce transaction costs. The future of Arbitram. Arbitram is not only an optimistic rollup, as the Off-Chain Labs team has announced that they will release other scalability solutions based on zero-knowledge proofs, whilst also improving their Arbitram 1 optimistic rollup L2. This is a good example of the trend of ZK-ification, where many projects are pivoting towards a ZK future, as the execution environment is much more flexible and arguably more scalable once the technical implementation of the ZK L2 is better researched and allows for generalized EVM computations. Optimism. Optimism is a public benefit corporation that built Optimistic Ethereum, which is an optimistic rollup L2 on Ethereum. In order to describe Optimistic Ethereum, I'll explain the similarities with Arbitram and then talk about some key differences in their infrastructure. Similarities between Optimism and Arbitram. They are both rollups and store all transaction on the layer 1. They are both optimistic since they use fraud proofs. They both use sequencers for instant finality. They have generic cross-chain messaging, allowing the creation of advanced token bridges, and they both support EVM-related tooling, but need specialized extensions. The differences. They have different fraud-proof verification mechanisms. Optimism's OVM 2.0 is EVM equivalent, versus Arbitram 1 post-Nitro, which is EVM compatible. Optimism uses single-round fraud proofs, versus Arbitram's multi-round fraud proofs. Optimism is still gated, as in there's a private whitelist, versus Arbitram, which is a public mainnet. There's a list of key tools in the original post as well that you can go take a look at. OVM 2.0. OVM 2.0 stands for Optimistic Virtual Machine and is the virtual machine that executes all transactions in the Optimistic Ethereum Layer 2. The OVM is getting an upgrade on November 11th, and Optimism is on a road to EVM equivalence. And in order to achieve it, they unveiled OVM 2, which will enable Optimistic Ethereum to be an equivalent compilation target to the EVM in all aspects. Developer tools like dApp tools and smart contract libraries and command line tools, Hardhat, Solidity, Viper, and all other tooling will work natively on OVM 2.0, without the developers of these tools having to worry about supporting fragmented codebases. This is the powerful network effect that everyone in the Ethereum community refers to. It is important to note that any competitor to the Ethereum virtual machine has to rebuild all of these developer tools from the ground up. Retroactive public goods funding. In my opinion, one of the most significant announcements that came from the Optimism team is they pledged to give away all their profits, totaling over $1 million, to public goods, and retroactively utilize quadratic voting. The Optimism team has also pledged to continue donating 100% of profits from the L2 sequencer to public goods moving forward. The profit is the difference between the generated transaction fee revenue and the cost that the L2 has to pay for submitting fraud proofs to the Ethereum mainnet. This sets a precedence for other L2s to follow in providing an altruistic outlook for the Ethereum community. Baba Network. Baba is an L2 Ethereum scaling and augmenting solution built by the Enya team as core contributors to the OMG Foundation. Baba is an Ethereum Layer 2 optimistic rollup scaling solution that reduces gas fees, improves transaction throughput, and extends the capabilities of smart contracts. Baba offers fast exits backed by community-driven liquidity pools, similar to other solutions like Connext or Hot Protocol, shrinking the optimistic rollup exit period from 7 days to only a few minutes, while giving liquidity providers incentivized deal farming opportunities. Baba started off as a fork of Optimism, and they are one of the key contributors to the OVM, the Optimistic Virtual Machine. An interesting fact is that Baba deployed the OVM 2.0 sooner than Optimism, which has the launch set for November 11th of 2021 on Optimistic Ethereum. Even though Baba started off as a fork, they do have a modular structure that enables them to swap the mechanism for submitting proofs to the mainnet, which allows for some upgradability or ZKification in the future. The team plans to completely rewrite the codebase for their upcoming v3, which is set to be rolled out on mainnet in the coming months. Baba's design also allows for smart contract extensibility and enables developers to build dApps that invoke code execution on web-scale infrastructure, such as AWS Lambda, making it possible to use algorithms that are either too expensive or impossible to execute on-chain. Metis. Metis is an L2 scaling solution on Ethereum that utilizes a parallelized or sharded optimistic rollup architecture. In the Metis VMOR, there are so-called decentralized autonomous companies, DACs, that have separate computational and storage layers that can be custom-tailored for the needs of the operators. These decentralized autonomous companies are the parallel execution layers of the optimistic rollup. DACs are fully interoperable and liquidity can flow in between them seamlessly thanks to their cross-layer communication protocol. Metis designed their scaling solution in a way where it could scale Ethereum horizontally without incurring significant infrastructure, according to their technical white paper. I met up with the Metis DAO team by chance during Liskin, and the way I understood the infrastructure is that it's meant to be a network that has different execution layers that are purpose-built for different groups that plan on scaling their operation, whilst preserving the security of Ethereum via fraud-proof submission to mainnet. There could be some public decentralized autonomous companies where common utilities like AMM liquidity for doing swaps that other DAC's users could tap into when needed thanks to the cross-chain DAC native interoperability. It's a novel design and an interesting experiment. Now we're going away from optimistic rollups to zero-knowledge rollups. Zero-knowledge technology has been heralded as one of the greatest recent advancements in cryptography, as it allows to give mathematical proofs to statements and conditions without revealing any of the information required to do so. Many smart people I've talked about zero-knowledge proofs say that it's essentially mathematical magic, as the proofs themselves are very complex and the mathematics can be quite hard to wrap your head around. From Vitalik's post on understanding rollups, ZK rollups use validity proofs. Every batch or rollup includes a cryptographic proof called a ZK snark or stark that is proved by a protocol like Plonk. After providing the post-state root is correct, the rollups publish the proof to Ethereum mainnet. I'll leave more resources for learning about zero-knowledge cryptography in the future reading section. One of the currently most sought-after goals in the zero-knowledge space is to create a zero-knowledge Layer 2 solution that is fully EVM compatible or equivalent. This is a very hard problem, but has been one of the biggest hurdles that many teams are working on. Many of the teams have announced solutions that do exactly this coming out in the near future. Most currently available solutions in production only act as a payment layer with limited functionality, like Polygon Hermes or Aztec, or have added functionality with their custom execution engine, as in their virtual machine, that's non-EVM compatible, like StarkX and Cairo, Loopring, or ZK Sync. Here's a list of zero-knowledge rollup L2 solutions. ZK Sync. ZK Sync is a zero-knowledge rollup L2 network built by Matter Labs. The currently available iteration of ZK Sync is not EVM compatible and supports payment functionality, limited smart contracts in a low-level language called Sync, NFT minting, and a few other functions. However, there is already a fully EVM compatible version of ZK Sync live on the Rinkeby testnet and is expected to launch on mainnet in the coming months. ZK Sync has been live since March of this year, 2021, providing services to platforms like Gitcoin, where users could pay for public good grants on the ZK rollup for a small fraction of the cost of using Ethereum mainnet. Anyone can bridge funds to the rollup via the native bridge and use the network for payments using ZK Wallet. The wallet also allows users to mint and receive NFTs on the network, as well as send and receive payments. There are also partners of ZK Sync that support ZK Sync payments natively, like the aforementioned Gitcoin integration. Most of the applications will start supporting ZK Sync once the network is EVM compatible. This is because standard Solidity contracts can be deployed on the network with minimal changes to the codebase. At current, all contracts on ZK Sync have to be written in the Zinc framework, which inhibits the network effect received from Ethereum mainnet. The ZK Sync code is fully open source, so anyone can check the source code contributed to their GitHub repositories. ZK Sync 2.0 is the name of the network upgrade that brings ZK EVM functionality and opens up the Space network to Turing-complete operations. It will fully support all the tooling that is used for writing smart contracts on Ethereum, whether it's core tooling like Hardhat, Ether.js, DAppTools, OpenZeppelin, Solidity, Viper, and others. Also, core infrastructure like the Graph will be able to index data on-chain in order to create better blockchain data fetching infrastructure for building scalable, decentralized applications. A myriad of projects is already planning to deploy their newest versions of their protocols on ZK Sync 2.0. This includes protocols like Aave, Curve, Balancer, 1inch, Argent Wallet, and others. It will also be supported by bridges like Connext and Hop in order to have cross L2 liquidity without having to bridge to Ethereum. Many teams have simultaneously been pursuing the ZK EVM as a piece of technology. The goal is to have full EVM compatibility or equivalence without compromising security in any way. The main goal is to have decentralized sequencer and validator infrastructure in place with full support for snarks, or Starks in the case of Starkware. ZK Sync's zero-knowledge EVM was delayed from its first ambitious deployment date of August 2021 due to various engineering reasons. If you want to try out ZK Sync 2.0, there is a Uniswap version 2 clone called Unisync, which you can try out on the Rinkeby Ethereum testnet. Moving on from ZK Sync to Starkware. Starkware is a company that develops Stark-based solutions for the blockchain industry. Their products enable secure, trustless, and scalable solutions for blockchain applications. One of the key contributions of Starkware Industries is its scientific research and technological advancements in the zero-knowledge blockchain computation field, with the invention of Starks, which stand for Scalable, Transparent Arguments of Knowledge. These are a form of validity proofs with a completely trustless setup that enables offloading all on-chain computation off-chain to a single off-chain Stark prover. Then the prover must verify the integrity of those computations using an on-chain Stark verifier. One of the best learning hubs for Stark is Starkware's Stark page, where you can read the academic papers that put the mathematical foundations and then dive deep into using Starks with code examples alongside various other helpful resources. More resources for learning Starks are available in the further reading section. StarkX. StarkX is an L2 scalability engine developed by Starkware that enables the execution of Cairo operations in a ZK environment. Its currently supported features are Volition, which is a hybrid on-chain off-chain data solution, self-custody, fast withdrawals, ERC 721 and ERC 20 support, L2 NFT minting, DeFi pooling, distributed AMMs, real-time Oracle price feed, tracking of interest and funding, and data availability, rollups, or Validium. Other features coming soon are data availability from Volition, unique minting, and interoperability with sidechain. StarkX generates validity proofs, which ensures that all the off-chain computations were performed with integrity. The Stark proof generated then gets verified on-chain before getting committed to Ethereum mainnet. DYDX is an on-chain derivatives platform that runs on top of a ZK rollup built by Starkware. The platform is completely written in Cairo and lives on its own isolated layer 2 where users can easily bridge funds from Ethereum mainnet and start trading with low transaction fees. The entire order book is on the L2, and so users have a much better UX than on the L1 without compromising security nor decentralization, as the rollup itself is permissionless and self-custodial with a trustless prover and verifier. DYDX is a custom implementation of Starkware's StarkX, and is currently the ZK rollup L2 that secures the most TVL, total value locked, with an approximate $1 billion in value locked. Starknet. Starknet is a permissionless, decentralized ZK rollup on Ethereum. It supports Turing-complete computations and will feature EVM compatibility out of the box via a Solidity to Cairo compiler. However, native Cairo code will be more performant. Starknet will also feature a range of data availability solutions, meaning that users will be able to switch between a ZK rollup and a Validium on a per-transaction basis. Since the L1 to L2 communication and the Stark prover and verifier will be fully permissionless and decentralized, the network will have the same security guarantees as Ethereum mainnet, whilst massively scaling throughput and providing a great and seamless UX. Starkware announced that they will be rolling out the Starknet Alpha on mainnet by the end of November. They are taking an approach inspired by their optimistic rollup counterparts, where initially the smart contracts deployed on the network will be permissioned, meaning that the Starkware team will have to approve the deployment of smart contracts manually. In their announcement, they also announced that future releases of Starknet won't be backward compatible with the Alpha, as they will restart the network state. There are additional features that will be rolled out as part of the Alpha 1 and Alpha 2, which include smart contract constructors, a better testing framework, block and transaction hashes, account and token contracts, support for contract upgradability and events, Warp, which is the Solidity to Cairo compiler developed by Nethermind, Ethereum signatures, and Starknet full nodes. Developers can already get started building for Starknet by learning Cairo to write, compile, and deploy smart contracts locally and on Starknet Alpha. There are also a lot of tooling and services being built around the Starknet ecosystem. Next up, we've got Polygon Hermes. Polygon Hermes is a permissionless, decentralized ZK rollup living on Ethereum. The Hermes ZK L2 and its team were acquired by and merged into the Polygon ecosystem. Polygon has a proof-of-stake data availability layer, a plasma chain, and is also developing scaling solutions that utilize optimistic rollups and various others. The Polygon Hermes team also announced their plans for full EVM support in a Medium blog post. They expect to launch a testnet by the end of Q4 2021, with a mainnet launch somewhere in Q2 of 2022. The Polygon Hermes protocol uses a very similar dynamic to the other ZK rollups mentioned above. It has an off-chain prover that validates transactions and generates a snark proof which gets submitted to the on-chain verifier. If the proof is valid, the new state gets committed and settled on Ethereum mainnet. For more details on Polygon Hermes infrastructure, you can visit their documentation. The Hermes team also has a white paper detailing the long-term vision of the project. It is a bit outdated by now, since the Polygon merger happened afterward, and the HEZ token doesn't exist anymore as there was a swap from HEZ to Matic. The HEZ was phased out entirely. Besides that and the fact that it's under Polygon's leadership, the goals remain the same: to bring massive scalability to the Ethereum ecosystem. Currently, Polygon Hermes can be used by anyone, however, it is not EVM compatible. It's mostly used as a payments platform within a ZK rollup environment. To use Polygon Hermes, connect to their web wallet UI using MetaMask or Wallet Connect and deposit funds into their L2, on top of which you can transact freely with other users for a fraction of the cost of Ethereum mainnet. Aztec Network. Aztec Network is a privacy-focused ZK rollup L2 on Ethereum. The Aztec Network L2 allows for fast, cheap, DeFi-compatible transactions in a completely private fashion, without compromising Ethereum security and decentralization. Aztec is built on Plonk, which is a universal standard for snark technology developed by them. Aztec 2.0 is the current iteration of the protocol and improved on various shortcomings of version 1. Aztec protocol features: identity privacy. With cryptographic anonymity, sender and recipient identities are hidden. Balance privacy. Transaction amounts are encrypted, making your crypto balances private. Code privacy. Network observers can't even see which asset or service a transaction belongs to. Scalable private access to DeFi. Gas-optimized versions of Plonk. And programmable privacy with Noir, the private contract language. As a user, you can deposit, shield your tokens by depositing them in Aztec. You can do private payments, encrypted balances and identities for all tokens. You have multi-device recovery. Your assets are protected from lost keys. You can withdraw and take your tokens anonymously back to layer 1. And you have an escape hatch. Even if all rollup providers go down, your exit's guaranteed. The Aztec team built a private wallet application called ZK Money. Users can deposit funds onto the Aztec 2.0 ZK rollup and shield their assets and transact on the network. Loopring. Loopring protocol is an open source ZK rollup protocol. It's a collection of Ethereum smart contracts and ZK circuits which describe how to build highly secure, highly scalable order books based DEXs, AMMs, and payment apps. Recently, they also added NFT mining and transferring functionality, and there has been an announcement of an NFT marketplace coming out by the end of Q4 2021. Moving forward, they also plan on adding an NFT marketplace, ZK EVM, distributed AMMs, multi-layer wallets and mobile, plus exchange improvements. As I mentioned many times in this article, the ZK EVM is a goal that almost every layer 2 out there is striving towards, in one way or another, as validity proofs have many advantages over fraud proofs over the long term in terms of security, scalability, and execution advantages L2s get from using one over the other. It is a trend that leads teams towards progressive ZK-ification. Okay, and here at the end of Loopring, I'm going to call it a day for part 1 of this guide, the ultimate guide to L2s on Ethereum. The next section will be diving into volition and validium, which is a word that I've already said a lot of times this time and in previous posts, and next read will start explaining that a little bit more. We'll also start discussing what benefits these protocols and this whole concept has to users, liquidity, and how you can build or use the L2s as a user. Now, this read-through is a little bit different from the ones I usually go through in the sense that the beginning is definitely kind of more abstract and general, and then we dove into a list of different tools and toolings. And I think the main takeaway that I'm taking away from this, and I think you should as well, is I hope that all of these names, all of these different terms, all of these different acronyms are already starting to make more sense for you. ZK EVM, L2, AMM, DAMM, there are lots of terms in the Ethereum ecosystem, but by now, through our read-throughs, all of this should start making sense. ZK EVM, Zero Knowledge, Ethereum Virtual Machines, and L2s, and all of that, as well as the different names for these solutions, Arbitram, Optimism, Aztec, Plonks, Starks, Snarks, all of this should really start to coalesce. And the main takeaway is just how much activity is going on in the Ethereum ecosystem to bring scalability in this Ethereum rollup-centric roadmap that we are going down. So that's where we'll leave it for this read. Next time, we'll be going through part 2.